Hello everyone. Today I'll be explaining perceptron, multi-layer perceptron and types of neural network. These are the foundation of deep learning, helping machines recognize patterns and make predictions and perform intelligent tasks like image and speech recognition. For example, perceptron predicting if an email is spam or not. For MLP, recognizing handwritten digits. In CNN used in facial recognition and RNN used in text prediction or speech recognition. So what is perceptron, multilayer perceptron and types of neural networks? Neural networks is a system of interconnected neurons that mimic the human brain. Now first the perceptron. Perceptron is the simplest neural network. It takes inputs, applies weights and predicts outputs. Now multi-layer perceptron. Multi-layer perceptron builds on this by adding hidden layers, allowing the model to learn more complex and non-linear relationships. For example, handwritten digit recognition, which uses in the MLP uses activation functions like ReLU, sigmoid, and tanh. Now the types of neural networks, in this there is CNN, that is convolution neural network, used for image and video recognition. RNN, recurrent neural network, used for text and time series data. GIN, that is generative neural network, used for image generation. And autoencoders, that is for data compression and denoising. Now how does the perceptron, multilayer perceptron and neural networks work? So first the perceptron, which is a single neuron. We take the inputs, apply weights to it, calculate the weighted sum and apply the activation function, and it gives us the output. That is for single perceptron. But for a multi-layer perceptron, we create multiple neurons and we create a network out of it. That is, the first layer is input layer, the second layer is hidden layer, and the third layer is output layer. In the input layer, uh, we take the inputs, apply weights. In the hidden layer, all the processing happens, and in the output layer we get the output. For example, in a chest x-ray diagnosis model, pixel data is taken as input and then weighted processing through hidden layers, and then in the output layer comes the final prediction. Now, what are the challenges and limitations of perceptron, MLP, and other neural networks? First is they require large data sets and higher computational power for training if you want high accuracy. Then they are prone to overfitting, especially with limited data. It acts as a black box, difficult to interpret internal decision making, and they can reflect or amplify biases present in the training data. So your training data must be consistent. For example, in data dependency, medical AI systems need thousands of label X-ray. For high computation, training large models like CNNs require powerful GPUs. And concerning the overfitting, a model trained on one dataset performs poorly on unseen data. So to sum up, neural networks are powerful systems inspired by the human brain. The perceptron founds the foundation. The MLP handles complex relationships, and advanced networks like CNNs and RNNs specialize in different tasks. They revolutionized fields like healthcare, finance, and language processing. For instance, a CNN can detect pneumonia from chest x-rays, while an MLP can predict disease risks based on patient data. In short, neural networks are at the heart of modern AI, driving the technologies we use every day. There are multiple applications to it, which are further not developed yet, but they are yet to be.